Hey, welcome back to the Relevant Combustion Corner. I'm Jeff Lorfing, Combustion Business Development Manager here at Relevant Industrial. And I'm so glad you're here. So sit back and relax while we talk about and bring you some of the hottest topics in the world of combustion.
Welcome back. Jeff Lorfing, Combustion Business Development Manager for Relevant Industrial. And excited today. Got a really dear friend of mine in the industry joining me to talk about some of the things that, are topics in our industry that we deal with. So on the last podcast we had, I talked specifically about burner management, right? So burner management being the safety portion of a combustion system in my mind, right? And so I talked about what that typical sequence looks like, and then we get into combustion control, right? I tell everybody that's kind of a line in the sand, right? That's when the safety system's done lighting the burner, we hand it over to combustion control. Then I talked about how we lean in on fuel air ratio control systems for low NOx applications. And that's really what I wanted to get into with you this morning, because we deal with it a lot, right? We get people that call us and they say, hey, I need a low NOx burner. And we know that's just the beginning, right? It's just the beginning. So talk a little bit about with me what we have to go through to spec out a low NOx burner.
Okay. Low NOx can mean a lot of different things. Every place around the country defines emissions differently. And then emissions are definitely defined differently outside of the United States. So here in the United States, we talk primarily NOx. And carbon monoxide, CO. Those are the two big ones we talk about. So anytime somebody says low NOx, you always want to start with, okay, what's the application? Where do we start? What are you looking to do? What are you trying to heat up? Is it a boiler? Is it a heater? Is it air? Is it a tube? What are we trying to heat up? And then what emissions do you think you need?
And that's the big one, right? And that's a lot of times we get a little bit of silence, right? They know they're being forced into a low NOx burner or a permit, but us knowing what those numbers are matter.
Definitely, because what we don't want to do is tell you, well, this burner can do this, and then they write that permit around what the burner can do. We want you to figure out what you need before we tell you what we can offer for you, because you don't want to write your permit around a number that doesn't work for you. You know, you want to make it as easy as possible to achieve the numbers that you said you can do.
Right. Yeah, and so that's the beginning of the process. And with that being said, we can't just tell you what a burner is going to do. Even though it's tagged as a low NOx burner, the application can change everything.
Absolutely.
Right? About how we apply that burner in that application. And so we work closely with you and the application team on these things to where we're going to go back to the customer and go through what we call the TPO process, right? So kind of touch on that. I know you did a little bit, but that process where we're getting all the information we need for the application.
Absolutely. No. And TPO is a document that we created that helps us define what your application is, what you need, what controls you need, what safety things we have to look at. Essentially allows us to help you guide your process to get the permitting and stuff done. So we use it to really determine how we can help you do what you need to do.
Right. And apply that burner properly, right?
Absolutely.
And then we also have customers that'll come to us and they have their permit, they know what they need for NOx and CO, but they need that letter of guarantee, right? Mm-hmm. And that's why that TPO form is so important, so that Maxon signs, they're liable for that, right? We work with that application team because they're liable for the performance of that burner in said application. And the guarantee, though, is going to be based on the information that's on that TPO.
Correct.
So that's the important part, right? Because sometimes if during startup commissioning, burners not performing the way they anticipated, we're going to have to dig into that and see why, right? It's because is the process conditions that you told us what you presented on the TPO. So that's important.
And it happens pretty often. We'll be out starting a burner up and it's not achieving what it's supposed to do. We'll go back and say, what did the TPO say? What did you ask us to do? So what do we need to do to, what was the application day one versus what today? Because if it's different, then we've got to figure out, number one, we're not just going to walk away. We're going to help you figure out what the problem is. And we'll go back in and look at the TPO and this is what's changed. Why has it changed? And can we get back to where we were, or do we need to adapt to the new application?
Right. So, yeah, so that's the point I really want to drive home is just low NOx applications, very application specific. We can't just, get you into a burner when you say, hey, I just need a low NOx burner, right? And then we get a lot of calls too about what NOx and CO can I expect out of an oven bag?
Yep. Exactly. And it depends. I mean, it really depends on the application too. Some applications you'll have no CO. Some applications you'll have a ton of CO. Some applications, well, the NOx is really kind of dependent on the burner, but the application definitely changes the emissions that you're going to look at.
Right.
And we have burners that will work in some applications and some burners that will fail miserably in some applications. So we have to make sure we get the correct burner into the correct application.
Yeah. So I guess the moral of our story is low NOx burners, very application specific. We got to have the data to make sure that we consult and we're getting you not only in the right burner, but it's going to perform like we said it's correct, right? So, and then we have burners. At what point do we call a burner ultra low NOx? So what point is that, right?
We've always defined, when we look at our line of burners, we kind of have normal emissions. We'll just say we don't even call it low emissions, just normal emissions. And then we move into a range between 30 ppm. And we really look at NOx. We look at a range between 30 and 50 ppm NOx for what we call low emissions. And then some people say single digits, whatever you want to say. So 10 and below, 9 and below is where we're going to call ultra low emissions is where we see that. So 9 ppm and below is where we're going to say something's ultra low emissions.
That's going to fall into the XPO.
Yep. XPO, Impacts, Optimas.
Yep.
Linox, there's burners out there that definitely can do it. But like you started with when you're talking about burner management versus combustion control,
right,
the control is as important as the burner itself as far as if we're going to achieve anywhere near the emissions you're looking for. You can go back to like we talked about your old tractor versus a car, a 4-barrel carburetor versus fuel injected, a Ferrari versus a 67 Malibu, who knows what it may be. Mm-hmm. The control makes a world of difference on how you're going to control
it. It does. And let's I want to go back because I did in our previous podcast, I did touch on combustion control and the types of like linkage, right? We got linkage style, you got direct acting, and then direct acting with parallel positioning, right?
Correct. Yep.
And so we're going to lean into parallel positioning every time for the most part.
Absolutely.
Right. And so I talked about SmartLink MRV. We rely heavily on that in the oil and gas industry. It's a very robust platform where we can go in and commission a burner, right? And I want you to walk through that. You've got more runtime with that than I do, but we commission a burner and we create a combustion curve across the complete firing rate of that burner. And we're checking emissions constantly, right? To see where is the air and gas across that firing rate. So just kind of walk through that with the viewers and kind of what's involved in setting up a SmartLink MRV system.
We have multiple ways to do it. SmartLink MRV is a again, like Jeff said, a linkageless control. You have an actuator on the gas valve. You have an actuator on the air valve. You may have FGR, you may have a second fuel. So you can have up to 4 different actuators direct coupled to these valves, these dampers or valves. And like Jeff said, is when we go to tune the burner, we kind of figure out, I always kind of say strike a line for the air curve, figure out what your max capacity is for your blower and make sure that matches up with the capacity of the burner. Strike that, you set your valve, your air valve all the way open for the max capacity.
Yep.
And then you go back and you start with your gas valve, and then you start tuning to emissions. You tune off pressures on the burner. If you have flow meters, you turn off the flow and pressures. You want to use as much information as possible. So the more instruments you have, the better you can tune this thing. And at the same time, you are monitoring emissions in the stack. So you're watching your CO and your NOx in the stack to make sure that it's tuning correctly. And you literally, like Jeff said, you go in each time and you set a point. Looks perfect. You move to the next point. Flame looks good. Emissions look good. Mark, strike it, move to the next one. You get all the way up to the top, and then you run back and forth through it, and your burner's tuned. It's as simple as that.
So, and how many indexes? Is 9?
There's not 9 or 18, depending on your state. There's 9 total indexes with half indexes. So you can have 0, a 0.5, and a 1.
Yeah, and keep in mind these actuators that we're talking about on the SmartLink MRV system. These things, 1/10 of a degree.
Yep, 1/10 of a degree.
So the resolution on these things is is there.
Yep.
Right.
You can adjust them for 1 degree or 1/10 of a degree, and tenth of a degree on a ultra low emissions burner is uber critical because it allows you to achieve that single digit number that you need.
Right.
A degree won't get you there. The burner will either go out or won't. Most likely it's going to go out, but you can adjust that gas valve by 1/10 of a degree on a quarter turn butterfly valve, and it'll tune.
They're so air sensitive, right? Because I remember you told me not too long after I started with Maxon about the cooler the flame, the lower the NOx, the higher the CO. The hotter the flame, the lower the CO, the higher the NOx, right?
Exactly.
And those burners get so finicky because dilution is a solution, right? Remember that one?
Exactly.
So we can cool that flame down by adding air independently of messing with the gas to get that flame tint down. But they're so sensitive because they're running so excess air.
Exactly.
Excess air. And then we run into other issues when we're tube firing.
Yep.
Right. Because of the tube pressures, and we start adding air, creates back pressure because we're not getting rid of that pressure in the tube. Boom, we snuff the burner out.
Exactly.
Right. What was the Widowmaker?
Yeah.
Right. the Widowmaker will start up on the XPO. Right.
Yeah.
You kind of you have to have some runtime with that burner.
Yep.
And we've got folks out there that do.
Yep.
Right.
Some burners are so temperature sensitive because the colder it gets, the more the higher oxygen levels in the air. So you're actually, just by the temperature changing outside, you're adjusting that fuel air ratio control because of the mass or the mass difference in the air. So cold air versus hot air is totally different, right?
Yep.
You don't feel it, but it really is. You're breathing in more oxygen when it's colder versus hot. That's why dragsters run better on cold weather.
Cold weather, right?
And so that burner we're talking about is, when it would get cold in the mountains, service person would get called out, leave his family, go out there and have to tune the burner.
Hence the name, right? So we had a little follow that one. Well, good. So yeah, that's really what I wanted to hone in on today because we touched on it. We touched on it last time, but I knew you were coming, and like I said, you've got a lot of history with the Smart Link MRV, and then the role it plays when we get into these applications, because we always want to take that consultative approach, right? We always, where we can talk to customers through their application, get all the details we need. We do a pretty good job at, getting into the right burner.
Yep.
Right. Exactly. So burning them safe, burning them clean. And then we get into some, the hydrogens, that we talk. I know we at the factory and Maxon, in most of the burners are hydrogen capable, ready. Some of them actually can fire on 100% hydrogen.
Correct. Hydrogen is such a fast burning fuel, and low emissions burners tend to mix much more thoroughly, which causes the flame not to be as far. So some of our ultra low emissions burners won't burn hydrogen, but most of the portfolio will, but some of the ultra low, because of the way the fuel mixes
at the nozzle
and the hydrogen burns faster than natural gas, you can't use an ultra low emissions, but you can blend. You can put some hydrogen in most of the burners. And some burners can run 100% hydrogen, and some burners you don't want to.
Well, we saw the TJ, the Thermjet, burn 100% hydrogen. Excuse me, at the factory.
Correct.
Yeah. So we got to see that, which was impressive. And then the other part of it was we were seeing how our Honeywell IFM flame technology was able to sense that hydrogen flame, and it's a solid solution.
What's very neat is how the flame actually changes from what your standard natural gas flame looks like, and then when you start to add, I think we did, I don't remember,
25, 50, 75, 100
intervals of hydrogen, just watching what it changes. It gets bluer and bluer and bluer.
Yep.
But all of our IFM products definitely saw it and worked well with
it. Yeah, which is great because that's, back to the safety side, right? Our flame detection is the first layer of safety, right? We got to make sure that we've got combustion at our target burner always. We have to take a corrective action if we lose it, right? So, all right. So hydrogen, it's a buzz, right? And you've got some people that are slipstreaming hydrogen, burning some hydrogen here and there. Obviously, the BTU content of hydrogen is so much less than natural gas, right? So that kind of gets into a whole nother topic. Exactly. But let's talk about when we were at the factory a few weeks ago, the hybrid
heating. Yeah, excellent.
Hybrid heating. So Maxon's doing a lot of work and out of Europe as well. The who's the gentleman there out of Europe?
Oh God,
he flew over. That's okay. I caught you off guard, but he flew over and
He'll be mad at me if I don't remember it. You'll cut this part out and we'll put the other stuff in.
But he came over and actually did us a presentation on the hybrid heating. They're doing a ton of tests. They even got some beta sites.
Yeah.
But walk the viewers through what we're calling hybrid heating and why we feel like that's actually going to be more of a feasible solution moving forward as everybody tries to do it greener and better. And I think, we're all about it, right?
Absolutely.
So kind of walk through, what does that mean when somebody hears hybrid heating?
Okay. Well, we'll start with, we originally kind of kicked off with, we'll back up a little bit to hydrogen, right? So the world, from a sustainability perspective, is looking for alternatives to natural gas, right? Hydrogen is one that's out there. For forever, people have been burning hydrogen fuel as a secondary or byproduct fuel in refinery, whatever. We've got this, we've got to get rid of it. Let's put it into the refinery. There's not a good source today for us to just burn hydrogen, right? So natural gas isn't going anywhere. But an alternative to that is electricity and a natural gas combination, right? So in order to make electricity, it's wind, it's solar, it's hydro and natural gas burning, coal and some other methods too. So with our burners, what we've looked at doing is there a way we can mix a natural gas flame with an electric heater as well. So what that allows us to do is, so far what we've done is air heating applications. We've got a large amount of air that we're trying to heat up, and we're running it through a burner for, say, let's bring something up to temperature on natural gas. And then once we're at temperature, let's switch over to hybrid heating or electric heating, and then we can maintain or keep a base load of electric. Right. So that allows two things. One, low emissions burners tend to have a lower turn down. So that low fire isn't as low as it needs to be for when somebody needs to get a high fire or something fast. So
they're always going to have their best emissions at high fire.
Exactly. The lower firing rate you get, the worse the emissions are, because you don't have the mixing energy from doing it. So what we've done is we've got natural gas burners bringing everybody up to temperature and then running it down to, or base loading or idling, you could say, on electricity. We turn on. There's never going to be enough electricity on the planet to eliminate natural gas completely. So what we've done is kind of allowed for customers, if you've got energy that you can use for this, you can spire up on natural gas with the emissions and then kick off to electricity to eliminate the emissions that you're getting from the natural gas.
Yep. Hence hybrid heating. Yeah. And we just feel like that's going to be a more sensible solution moving forward, to the point you bring up about, 100% hydrogen, right? And just the energy, like we live in the oil and gas, petrochem refining world. And yeah, that's, 100% hydrogen's kind of out there, but what do we do with it? How do we make it better? We do run into some customers that are burning it. I call it slipstreaming it, mix. And sometimes too, we had an instance where they started doing that. We ran into flame detection issues, and that can be a whole nother thing, introducing that other fuel is going to change that flame signature.
Absolutely.
And the radiation that's being emitted to that scanner. So it kind of brings on a whole nother set of challenges.
And our scanners allow you, when you have to change the tuning constants or the parameters within the scanner, if you're running a natural gas, you have one setup, you will know when you're switching over to that slipstream, and then you switch your tune settings, right?
Yep.
And you say, okay, now I'm looking at hydrogen. Now I need to use these parameters to measure it instead.
Exactly. And that's really a neat feature, whether it's that application or you start up on a natural gas fuel, kind of easy breezy. We've got plenty of UV available. And then, we get into some off gases or plant gases, and then we get up to temp, and now we've got hot radiation that could affect our scanner, right, with some low frequency IR. And so we have the ability, based on process conditions, to say, hey, go from a natural gas tune to a sour gas tune or whatever we're introducing into the burner that's going to change that flame signature, and then we can reliably change that back and forth. So
exactly. And that's all part of the process walk when you
yes, it is. You had to go there.
Do a straight face.
Yeah. You had to go there.
It's all part of the process walk when you tune up one of these burners, when you tune up one of these flame safeguard systems or IFM scanners.
Almost like it's just kind of like tuning, right? We walk it across, and based on, what's introduced to the burner, and we see how is the flame detection is reacting, because here again, safely and reliably telling us that we've lost that flame in our turbine. Yeah. So good stuff. really been wanting to talk about the low emissions thing because we're getting into it more and more. We hear it more and more, which is great. It's fantastic. Like I said, for viewers to understand kind of what goes into that, right? And we, like I said, we do get a lot of those just calls where folks are reaching out and, hey, I need a low NOx burner. And, we're here to walk them through that process. The last thing I want to talk about, back pre-COVID, COVID, Honeywell, the factory, right? A lot of folks been upset with, us, Honeywell, Maxon with the factory, but I got a chance to go there a few weeks ago. And it's been, I guess, a year or so since I've been there, but the factory looked phenomenal. The work, it's insane, the work that has been done there. You and I got sent there when it all kind of started to unravel, and we were literally in totes and clipboards, writing down what was in there and hanging it on there, moving to the next, just trying to inventory when Eclipse moved over to Maxon, right?
Exactly.
It was insane with the VLM systems in there, the mezzanine, got the autonomous
AGVs running
around, getting parts, picking parts, but so much better.
I've watched it from Jeff and I were both there prior to a transition, right? When we combined two factories together, and the plant ran pretty smoothly, right? It was one product line. It ran very smoothly. Our deliveries were great. During COVID, obviously nobody knew what was going to happen. So we decided to combine two factories together to make sure that it was, we were ready for what's going to happen depending on what happened, right? So that transaction or transition didn't go as according to plan. Like Jeff said, it was kind of like they just took everything and put it in a box and took it from the shelf that it was on and just moved it to a city, right? Now we had to go figure out what everything was. So we finally have all of that unloaded. We have all of everything. We know where everything is. Our inventory management is better than it's ever been. With the parts, the inventory levels, all that stuff is acceptable. Our lead times are still coming down. We still have some outliers out there that are causing us issues, but the everyday stuff, the lead times are back. I mean, we are we're back to. Everybody has this recollection and we were always really, really fast, but according to the reality, we weren't always as fast as we thought we were. We just didn't really have any delivery issues. So our lead times are back for the most part. So now we're just trying to streamline everything and make it even better.
Right.
People are shocked when they're getting the products that they've ordered because of how poorly we are delivered. Exactly.
Yeah,
we've delivered over the last few years.
Right.
But our saying this year is we're back, right? And
we're back.
We truly are.
And that's why I wanted to talk about it because you and I joked around because, there was 2 or 3 years we were like professional apologizers.
Yeah, that's all we did.
That's all right. Yeah. We knew how to apologize in every way. But you pick up the phone, Honeywell, this is Jeff. I'm sorry. That's just how you started the phone call, right? But I just wanted you to talk about that. And I actually wanted to get Tim on one of these with us because Tim can talk at the factory, right? Yep. I mean, you've been there, like you said, from when the wheels kind of fell off the apple cart, right? But I wanted to highlight it because I was really blown away. They are doing so much better. And for those of you out there that don't have any point of reference, a lot of the industry knows Maxon was bad, right? Mm-hmm. And which is a lot of the reason why we started all our stocking initiatives. We stock just a ton of the safety shutoff valves and things because that can be very reactionary, right? When somebody has a safety shutoff valve that's down, they need a valve, right? And so we put ourselves in a position to serve that market. But the other part was the motivator was lead times, right? Yeah. We were trying to shield our customers from the 16, the 20 week lead times. But you guys are so much better and the factory looked amazing.
And with our channel partners, the experts at our channel partners are able to take customer asks for X, like Jeff's got Y and Z, they can help them figure out, and we can make this work. Customers listen. Because if they're down, they need to get back up.
If they're down, that's a great point because we're going to put the Ferrari of the valve on the shelf, right? I mean, if you got a NEMA 4 valve, I got a NEMA 4X, I can put it there. If I've got a C1D2 valve, you got general purpose, we can put that there, right? Because generally it might not work the other way around. Well, it doesn't work the other way around.
It shouldn't work the other way.
Yeah, right. Especially if it's a classified area. But does it matter? You've got one closed switch and one open, and my valve has two closed and two up. No, right? It just doesn't matter. So, but well, great. So back to fuel air ratio control, smart link we talked about. Talk for a minute. One thing that we didn't touch on is the smart link is getting its control signal from either a single loop controller or a PNID that's running in a PLC or DCS mode, right?
Absolutely.
So it's just going to take that 4 to 20 into the smart link. And at that point, the smart link then determines, based on that curve that we developed in the field, where does fuel go? Where does air go?
Okay.
Right.
Yeah.
So another product that is starting to get some lift and some traction in the market is Slate.
Mm-hmm.
Right. Slate. And that's, that term came from a VOC that was done for that product. And the customer was like, hey, we really just want to kind of a clean slate, right? Where do we start over? And the unique thing about Slate is burner management. It's a burner management system. It's a combustion control system. It has a FM approved limit. It has all it's modular by design, but it is a combustion system that's CO2 capable, right? So unique.
Still 3 capable.
It's still 3 capable.
Still 3 capable.
Still 3 capable.
Not still 2.
So relative to that is the combustion control, the FARC, fuel air ratio control module. Talk about that, right? So we can employ that module in Slate to do exactly what we were talking about.
Absolutely. The SmartLink MRV, like I said, is a 1 to 4 valve system. Slate replicates that, duplicates that, as well as gives us some capabilities, some additional capabilities. So SmartLink MRV was done with actuators, servo control actuators. Slate uses very similar actuators, servo control actuators, but it also has the capability of doing O2 trim.
Yep.
When we talk about emissions, we talk about combustion control, whether it's emissions or not, combustion control is also O2 trim. Every car out there, every modern car out there has an O2 sensor.
Yep.
And that's why you can run any octane fuel through there, because of that O2 sensor. That's what makes the difference, right? So Slate gives you the ability to use O2 trim, whereas SmartLink MRV did not. We had some legacy ones that used to use flow meters. We do mass flow control.
Yeah, Smart Fire.
One way to do it, Smart Fire,
yep.
Where you're actually counting molecules. I've got 10 airs to 1 gas, yep. and it's modulating all the way up the firing rate and back to make sure the ratio stays.
Metering system.
So as temperature changed,
yep.
that swing was handled because of the different molecules of the mass was going through. It's mass flow versus just a position control. Slate does something very similar with O2 trim. So you can hang O2 analyzer on the stack, and then you can control or trim back to O2. So you have not only the set point coming from your PID controller telling it where to go, you have an internal PID loop that's controlling to O2. So we're trimming the air valve, either the air valve, or we also have the ability to do 4 to 20 with a VFD or even another control valve.
Yep.
But Slate gives you ability to run a VFD. A lot of modern control systems want to run VFDs, and Slate gives you that ability.
Yeah, very good. Yeah, so that, Slate, from a combustion system standpoint, modular by design, to where historically we would have our M7800 handling burner management. We would have a FM approved limit in the door for the high limit, what required. We would have,
let's not forget first out enunciator.
That's where I was going, because Honeywell, up in Canada, the S7830, which was the old enunciator, is still a ton of them out there, right? Well, they did bring that module back with that platform, so you can have a form of first out enunciation, which is so critical when you're especially burner management, right? Because you got a critical limit string, something in that string drops, it kills your burner. And, as a technician, you walk out there, if you just got, hey, burner fail,
yeah.
where do I start, right? So you're with your meter, hoping if it was a pressure switch, it still dropped out, right? To where you see where it broke. Whereas the first out enunciator captures that, where it broke, and the troubleshooting is so well good. I just wanted to touch on Slate as it relates to our topic with fuel air ratio control.
Yeah, perfect.
So,
it fits.
It does. So thank you, Matt.
Appreciate it. Thank you.
This has been a blast. Appreciate you being here. I'll come back to Dallas again if I have to.
Always for the good barbecue.
Yeah, we had Terry Black's last night.
Oh, nice.
I think it's one at Austin too, right? Yeah. So Terry Black's, good stuff. Got a T-shirt.
Nice.
Yep. And I woke up, my room smelled like brisket because the smoke in that shirt was. I was like, man, what is this?
It's going to say better than baked beans.
That's right. So, but anyway, hey, thanks for joining us again. Yeah. I'm Jeff Lorfing, Business Development Manager for the combustion business at Relevant Industrial. We'll see you next time on the Combustion Corner.
Appreciate it, Jeff. Thank you.
Thank you.